This is the lecture for the chapter 2 in statics, the section 9 about the dot product. So I will explain you the two formula that we will use for the dot product and how we use the dot product in statics, specifically in statics. So first, let's come back on the definition of the dot product. So the dot product is a product between two vectors. For example, vector A and vector B. Okay. The first definition of the dot product is A dot B is equal to the magnitude of A times the magnitude of B times cosine of the angle between A and B. So this angle there, theta. Okay, that's the main definition. The dot product is a scalar. Okay, but the unit of the dot product is the unit of each vector multiplied together. So if A and B are two lengths, the dot product will be a length square. If the two vectors are two forces, the dot product will have the unit of a force square. Okay, so that's the main definition. If we look at two specific configuration, if A and B are parallel to each other. Oops, sorry. Here we go. We have A dot B that is equal to A times B times cosine of the angle between the two vectors, that is 0. Okay? And cosine 0, okay, that's the little triangle there, circle there, trigonometric circle. So cosine 0 is 1. So it's equal to A times B. Okay, so if two vectors are collinear, the dot product between each other is just the magnitude multiplied, both magnitude multiplied together. If B was in the opposite directions, in these directions, but still in the same line of actions, A times B will be equal to minus A. So the vector A dot product the vector B will be equal to minus the magnitude of A times the magnitude of B. Okay, specific configuration. And now if A and B are perpendicular to each other, the dot product A dot B will be equal to A times B times cosine 90 degrees, and cosine 90 degrees it's 0, so it's equal to 0. So the dot product of two perpendicular vector is always 0. Why I spoke about that? I spoke about that because we will need that to prove the second definition. Okay, so first definition, that this one. Okay, the second definition that we will use comes from, let's put the scalar there, comes from the fact that two perpendicular vector together, the dot product is 0, or two collinear vector are just the magnitude multiplied together. Okay, let me explain that. So A, let's say we know A as a Cartesian vector form, so Ax I hat plus AY J hat plus AZ K hat, and we also know B. So B, let's say it's Bx times I hat plus By times J hat plus Bz times K hat. Okay, we know both vector. So if we take the dot product of A dot B, it will be Ax I hat plus AJ AY J hat plus AZ K hat dot Bx I hat plus By J hat and plus Bz K hat. Okay, I know it's long and it will be much longer. I will develop everything. Okay, so A dot b. So first I will develop ax I hat, and I will multiply by each term for b. So it will be ax bx time I hat dot I hat. Okay, I put together the magnitude and together the vector, plus ax by time I hat dot j hat, plus ax time bz. Move a little bit. Oops. Time. Oops. Here we go. Time I hat k hat. So that's for the ax. Now let's develop the ay. So plus ay bx time j hat time I hat, plus ay time by time j hat dot j hat, plus ay time bz time j hat dot product k hat. So that's for ay. And now for az. So plus az bx k hat dot I hat, plus az by time k hat j hat, and plus az bz k hat dot k hat. I know it's a bit long, I just do it once. Okay, and what we say just before that it's two vectors are perpendicular to each other, the dot product is 0. So because I, j, and k are all perpendicular to each other by definition of those vectors, that's the unit vector of x, y, and z. We have I dot j that's equal to 0, I dot k that is equal to 0, j dot I that is equal to 0, j dot k is equal to 0, k dot I 0, and k dot j 0. And because I, j, and k are perpendicular to each other, not because they're perpendicular to each other, sorry, I dot I, j dot j, and k dot k, the two vectors are collinear together. So the dot product is just the magnitude multiplied together. And the magnitude of I, j, and k, it's equal to 1 because that's unit vector. So this is equal to 1, this is equal to 1, and this is equal to 1. So finally, the dot product is equal to ax time bx, the complement on x multiplied together, plus ay dot by, and plus az dot bz. Okay, and that's the second definition of the dot product that we will use. Yeah. Okay, so that's two important definitions, but this one comes from this one come from this one. Okay, so now that we have this, what can we do with that? There's two important things that we can do. Okay, first, we can find, because those two equations are equal to each other, so we can write that. Let me just organize a little bit this. Okay, so if you write that a dot b is equal to a dot b, that we all agree with that, and we take on the left the first formula, and on the right the second formula, it means that if we have any unknown, just one in this formula, we are able to find it. So let's say the unknown here is theta, the angle. We can use this formula to write that theta is equal to the inverse cosine of ax bx plus ay by plus az bz divided by the magnitude of a times b. And I mean the magnitude of a is the square root of magnitude of a is equal to the square root of ax square plus bx square plus, oops, why did I write b? Sorry, ay square plus az square, right? And the magnitude of b, that's for a, and the magnitude of b, that's the same thing with bx square plus by square plus bz square. So if you know the coordinates on x, y, and z of two vectors, you are able to find the angle between both of them. So this angle theta, this one, using the dot product. So that's this important formula there. Here we go. One more thing. Let me take my ruler there. Let's get it this into. Here we go. Okay. Now we will use what we learn, and we will use an axis that I call A and a force F. Okay. And the goal is to find the force F on the axis A. Any axis A. Okay. That's not, let's say that X, that's Y. Okay. This axis A, it's somewhere, it's not on X, Y, or Z. Okay. How can we find FA, the projection of F on the axis A? And maybe also we can speak about this angle theta between both of them. Okay. So let's look at this. If we do, which color? I will take purple to do a little UA. UA is the unit vector of the axis A. Okay. If we do F dot UA, it's equal to what? F, the magnitude of F, times the magnitude of UA, that is 1, times cosine theta. So F dot UA is equal to F cosine theta. What is F cosine theta? F cosine theta is FA. So F dot UA is equal to FA. That's the complement of the force F along the axis A. Okay? And how do we find F dot product UA if we don't have cosine theta? We use the second formula. So we also have F dot UA that is equal to Fx UAx plus Fy UAy plus Fz UAz. Okay. So finally, we can say that, oops, the multiplication is there. We can find Fa using the Cartesian notation form of the force F and the unit vector UA. So Fa equal Fx UAx plus Fy UAy plus Fz UAz. So we multiply them together. One more formula that we will use. Oops. Okay. And one last thing, if we have FA, so that's this complement there, and now we want to find F, let's call that FB. It could be FB. You will see on your lecture also, this one is called F parallel, and this one is F perpendicular to the axis. Okay, how do we find FB? So this complement there, that is also this one, FB. We can use the Theorem of Pythagora. So we can say that FA square plus FB square is equal to F square, or F parallel square plus F perpendicular square is equal to F square. So if what is given is FA, that we just found with the dot product, and F that we are able to find with the formula with the square root of each complement square, we can write, and FB is the unknown. Okay, I try to use red for unknown and blue for given. We can write that FB it's equal FB square is equal to F square minus FA square. So FB is equal to the square root of F square minus FA square, or F perpendicular is equal to the square root of F square minus F parallel to the axis square. Okay, so you can write this formula. So we'll need to find the second complement of the perpendicular complement of the force. Okay, so everything that I squared in red is the formula that we will need to solve your problem. Let's put it there. Okay, so you have everything on one page. I will save this formula. You have the demonstration of everything. You don't have to remember the demonstration, but you know now from where all those formula are coming from. Okay, so now you're ready to take your problem and examples. Bye-bye.